if one of the parallel plate, so let us take a parallel plates like this, parallel plate capacitor, and one of the plates, say the first plate, is gradually lifted about this fixed point. So it is lifted gradually about this fixed point. That means what, after t seconds, this angle may be like uh, theta. So then what is the variation of capacitance of this capacitor? We'll see. Capacitance of tilted plate capacitor. So let us see the capacitance of tilted plate capacitor here, and the length of the plate will take as L, and the separation, initial separation between O and this A, say D. Let us consider a small elemental area, this part, and here this part. Okay, small elemental that area, and which is at X. So here, what is theta? Theta we can write, or what is this distance? This distance we can write as, say, some y. That y we can write as x theta. Let us take here mn. This mn is how much? The separation we can write as, up to here it is d, and remaining is y, d plus x theta we can write. So let us calculate, let us write equation for capacitance. So for at x distance, for considering elemental capacitor, that elemental capacitance dc we can write as epsilon naught area. What is the area? See here, thickness of the width of the plate, let us take b. Width of the plate is b, and how much thick we take here? Dx. Dx element we have considered. So for that element, what is the area? If you take as dA, it should be b dx. So epsilon naught b dx, epsilon naught a by distance. What is the distance? D plus x theta. So this is the capacitance of that elemental capacitor. See what is happening here when you tilt the first plate, and the variation taking place along the length of the capacitor. Of course, along the height, that is separation between the plates of the capacitor also you can do. But simple, easiest thing is along the length. If you do, you will get final value. Okay. So total capacitance is equal to integral this dc from 0 to L. Here in the denominator, d also will take common. Then that we can write outside of the integral epsilon naught p by d integral 0 to L dx by, because here d is taken common, 1 plus x theta by d, this we can write. So this is epsilon naught p by d 0 to L, you can write it as 1 plus x theta by d power minus 1 dx. So from above equation we can write epsilon naught b by d integral 0 to L 1 plus x theta by d power minus 1 dx. There you implement 1 plus x power n form, so it becomes 1 minus x theta by d in the bracket. After integrating and substituting integration limits, so the final capacitance is, if you take L common, so L we can take common, then epsilon naught b into L is the area by d into 1 minus L theta by 2d.